So 4.5 is exponential, if I can spell, and logarithmic equations. So basically we'll just be solving equations using logs at this point, like solving for x. So all right, number 12. So these ones say, so this is like a huge chunk of the problems. Just says to solve the equation. They have some other things like give the answers in exact form, give the answers as decimals. Like, I don't really care about that part. I just want you to solve the equation. Whatever logically makes sense, we'll do that. So, number 12 is 5 raised to the x is equal to 13. Turn this thing off. So I want to solve for x, and this isn't one that I just know right off the top of my head. I don't know 5 raised to what power gives me 13. That's a super weird one. If it was 5 raised to the x equals 25, like I could pretty easily figure that out. That's what we've been doing. So when I have an exponential, so something raised to a power, I use a log to undo it. And so what that means is we will start up here, we come down, and we make an L. So when I have an exponential, I need a log to solve it. I make an L. And this says log base 5 of 13 equals x. So it always starts log base 5 of 13 and then back around the equal sign equals x. And then at this point, we would just use the log base function on our calculator to do this. So again, that's under math, and then arrow up to log base, and then we just type it in, which you should be pretty familiar with. So that ends up giving me x is 1.59. I think they say to go to 3. Yeah, they want to the hundred or the thousandths place, so we'll go out, which rounds us to 4. So 1.594. On those. Let's see, 16.6 raised to the x equals 3. And so some people get confused about this. I know we've done a teeny bit with this. Like I did a couple showing you the like L method earlier on in the chapter. But for us to do it, the exponential part has to be on the left, or this drawing the L doesn't work. Okay, so it has to be set up to look like this, of whatever the number is raised to the power is equal to something else. Otherwise, it won't work. So I come down here, so it'll be a log base 0.6 of 3 equals x. And then we just type that one in. And this gives us x is equal to negative 2.151. And I'm rounding, obviously, on these numbers. They're not coming out to these perfect 3-spot decimals. Let's see, 22. This one is e to the x to the 4th, so it's e raised to the x to the 4th, basically, and then is equal to 1,000. So I treat the x to the 4th as like if it's the only thing that's there. So just think about that as like 1 unit when we're going to like do this. So I'm going to have log base e of 1,000 equals x to the 4th. Well, what is log base e?
ln.
Yep, ln. So you can either write it as log base e of 1,000 equals x to the 4th, or the way that I would write it is the ln of 1,000 okay, because ln is just log base e, equals x to the 4th. I would find out what the ln of 1,000 is, which is 6.908, and it keeps going. Now, just like when we solve like a normal equation, if I have x to some power, I obviously need x by itself. I undo it by taking that root, which is the 4th root. So I'm going to do the 4th root of both sides. Now, I don't know if I've showed you this part before, so let's do this. So the ln of 1,000 is what I just did here. And if you're using your calculator, you can do this all in one step. Don't feel like you have to do it in separate steps, but if we go back, I just want you to be able to see what we did. So under math, over here, so we normally arrow up to get to log base, but if I arrow down, you'll see that I have a cube root and then I have an x with a little root, and I know it's kind of hard to see on the screen, but this is the option that we're going to choose here. Okay, so option 5. Now, it's going to take whatever my last answer was and use it there, so I'm going to have to overwrite that with a 4. But now this is the 4th root of, I can either retype in ln of 1,000, or because that's the last thing that I had on my calculator, I can hit second and then down here, the negative sign. Again, really hard to see, you'd have to look at yours, but it says A and S, which is for answer. So if I hit that, it brings up the answer to the last thing I had typed in, and it will now take the 4th root of my answer, which is 1.621. And that would be x. But you could also have done, so math down here. Oh, I forgot to do it. Override it. The 4th root of the ln of 1,000 if you wanted to just do this step from the beginning, and you get the exact same thing, so nothing different about it. Now, it could be, your answer could be off by like a decimal place or two if you use the rounded answer. It's not wrong, you're just using a rounded answer, so just know that at that 2nd or 3rd decimal place, your number may be slightly different. Not something I'm gonna fret over. You're not gonna lose points off of a decimal place. That is something I can tell, like, okay, you used a rounded number. Now, if it's like drastically off, yes, you're gonna lose points, but not for something like that. Any questions about that or typing that into the calculator? All right. And obviously, if y'all have questions about typing stuff in as you are working on problems, just let me know and I can go back over stuff. I don't know how much y'all like learned in years past about how to use your calculator and things that your calculator can do for you. So I always try to do it as if you've never seen it before, but if you ever have and you're just like, yeah, we already know how to do this, you can just be like, oh, we're good. So, all right, jumping down a little bit to 28. Got a little bit more involved with it. We have 1.2 times 0.9 raised to the x equals 0.6. So the only way that I can do this L method is if it's set up like this, where I have something raised to a power that has the exponent in it, or not the exponent, the variable in it is equal to something else. So what's different about this problem that I just put up here, number 28? Compared to like the last couple.
There's 2.
Yeah. So this number here is being multiplied by this. So I can't start out right away by doing the L. So I need to, since this is being multiplied, I need to divide both sides by that. Okay. So that I get it down to something that I can work with. So this is going to be 0.9 raised to the x is equal to 0.6 divided by 1.2. Which is 0.5. So now that it's set this way, I can do the L. So log base 0.9 of 0.5 equals x. So that gives me, oh, too far. 6.579. And that would be my answer on that one. Let's see, one more thing I want us to see in these ones. 34. 6 times 1.024 raised to the x minus 1,900 equals 9. So when I do this, I obviously, like I did on the last one, I need to divide by 6 first. So let me go ahead and do that. So I'm going to have 1.024 raised to the x minus 1900 equals 6 divided by 3 is 3 halves or 1 1/2, however you want to write it. It doesn't matter. Now, I can do the L here because there's nothing else in front. But what it's equal to is this entire piece that's in the exponent. So it's going to be log base 1.024 of, I'm going to write that as 1.5 just for the ease of typing it in, equals x minus 1900. Okay, so I'll type this in, which is so this is 17.096, which is equal to x minus 1900. But I need x by itself, so now I'm going to add the 1900. So I just wait till the end to do that. So plus 1900, not that many. So that gives me 1,917.096. And that's my answer. Any questions on those? All right. So those ones are exponentials, and we use a log to solve them. We're getting ready to move into logs, and we're going to use an exponential to solve that. So that's going to be the little curly Q, or the E, as I like to call it. So starting out with an easy one, 42. 3 ln of x equals 9. So anytime I'm going to do my little curly Q thing or whatever, I've got to get it to where it's just the logarithmic function on the left. Just like we on these ones, I had to get it to where it was just a number raised to a power on the left. I had to move everything else over. I need to do that same thing here. So I'm going to divide by 3. So I'm going to have the ln of x equals 3. So now when I do this, I start at whatever the base is. Now the base of ln is what? Yep, so it's going to be e raised to whatever. So I come here and I loop around and it always follows in order. So e raised to the 3 equals x. And on these ones, sometimes people just leave it as e cubed or they'll type it in. Honestly, either way is fine, but if you do, there's just remember there's an E button on your calculator. I think y'all probably remember this or maybe have noticed this, but it's going to be hard to see. But anyways, over here on top of ln is the E, the little, like the lowercase e. Okay, there's also uppercase e's above the comma. That is for scientific notation. Okay, so you're looking for the lowercase e when you're doing this, which you probably know, but some people mix them up and then they get a totally different answer. So we've got e to the 3, and so if we were to multiply it out, it would be 20.086 is x. So I would take this either way, because like I said, some people just leave, since e is a number, they'll just leave it as whatever, cubed. See, 46. The log of 3 minus x equals 0.75. So what is the base of this log since it's not written? Yes, 10. I was going to say add a 0. So anytime you have just log by itself, that's always assumed to be base 10. ln is base e. Anything else, they're going to give it to you. So I start down here, loop through. So this is going to be 10 raised to the 0.75 equals 3 minus x. So 10 raised to the 0.75 is 5.623. I'm going to go ahead and just to save some time and some stuff, I trust that y'all can do that. I'm going to subtract the 3, which gives me 2.623, and then I'm going to divide by, well, here, let me do this. 2.623 equals negative x, and then I just need to divide by the negative, so I can make the number negative. Negative 2.623 equals x, and that would be our answer on that one. So I multiplied this, or not multiplied. I did this, like raised this to the power, and then I subtracted 3 to get to here, and then I divided by the negative to get my final answer. All right, a couple that we need to use some properties to solve. 52, log of x plus log of x squared equals 3. So we had some properties in, what was it, 4.3, I think. We had log of a product is equal to the sum of the logs, log of the quotient is equal to the difference of logs, and the one with you have a power, you throw it out front, or if it is out front, you throw it inside as like an actual power. So I have two things being added together, so what do I do here? Yep, multiply them, so I'm going to have x times x squared, which is what? Yep. They have same base, so we add their exponents. So now I have log of x cubed, and keep in mind you can only do this if they have the same base, which in these problems are obviously going to give you that, but just saying. So now this is something I can work with. I couldn't do it the way that it was before. So I start here, loop around. So I've got 10 cubed equals x cubed. Now, what must be true? Yep, x has to be 10 because both of these are cubed. So without me having to even do any more work, 10 has to be equal to x because I took cube root of both sides. 10 and x. All right, I want to show you something on these next two. They're not ones that you need to stress about as much. I'm not going to say like you aren't going to have one, but I just want you to mainly see them. So I've got the log of x plus the log of 3x minus 13 equals the log of 10. So this one is different in that I also now have a log on the right-hand side, but what's true about all of these logs? Yep, they all have the same base of 10. So I can do the same thing on the left side here that I just did in this last problem. I can multiply the stuff that's inside. And so that's going to give me the log of, I'm going to go ahead and distribute it through. So the x times the 3x and x times negative 13. So the log of 3x squared minus 13x equals the log of 10. So something that we haven't talked about yet, but if you have two logs that are equal to each other and they have the same base, the stuff that's inside of them is equal to each other. So that means that 3x squared minus 13x is equal to 10. And now I'm going to solve this just like I would solve a normal equation if I didn't start with logs, which you can't see if I put my hand over it. But anyways, so you're going to move the 10 over. So I'm going to have 3x squared minus 13x minus 10 equals 0. And then I need to factor this to solve. So I need factors of negative 30 that add up to give me negative 13. What might that be?
Negative 15 and 2.
Yep, negative 15 and 2. At my first glance, I was like, oh, it's going to be 3 and 10. And, like, they're both going to be negative. And then I was like, oh, that's not possible. Sometimes they're nice like that, but not always. So now I know this is going to be a little bit of a refresher. We haven't done this in a while. So we've got 3x squared minus 15x plus 2x minus 10. Factor by grouping. And if you have a different way that, like, you learn to factor that's easier for you, obviously you can do that. This is the way I was taught. This is the way I do it. So I take out a 3x, and I'm left with x minus 5. Over here, I'm going to take out a 2. I'm left with x minus 5. These match, so we're good to go. So I've got 3x plus 2 and x minus 5 is equal to 0. Then I've got the 0 factor property, which says I can set each piece equal to 0. So I have 3x plus 2 equals 0 and x minus 5 equals 0. So over here, subtract the 2, divide by 3. So x equals negative 2/3. And over here, x equals 5. Now, one thing here that you have to know about logs. I don't know if it was in your notes anywhere or if we've talked about it yet. I cannot have a negative inside the log. Okay? That doesn't mean I can't plug in a negative number, but the value of the log itself, like that's inside, once everything is simplified down, has to be positive or 0. Okay? So, up here, if I plug in the log of negative 2/3, that's going to be a problem. Okay, because I can't have a negative number. If you ever were checking it in your calculator, the log of negative 2/3 is going to tell you that you have a non-real answer because that can't be in a log. Okay, so when I get a negative number down here, I'm going to cross that one out and just circle the positive one that actually works. Okay. Now, in this one, if I had plugged in, well, in this case it would have worked, but sometimes the negative numbers are okay. Like I said, if I had plugged it in here, it might, obviously, it's still going to be negative in this particular case because it's going to be negative 2 minus 13. But sometimes one of them will be fine, so you got to check it in each piece of the log to make sure. Don't just be like, oh, I got a negative x value. That automatically means it doesn't work. Check it in the original to see. But in this particular case, x equals 5 is the only one. Now, if on a quiz or a test, you left x equals negative 2/3, you forgot to check it, that's probably like 1 point off. Nothing super crazy. But obviously, every point that you can get is good, so try to remember to go back and check it. Any questions on that? All right. One last problem. It's kind of like this one, but a little bit different. Number 80, and then we will be done. This one's a little faster. ln of e to the x minus the ln of e cubed equals the ln of e cubed. So all of these again have base e. So anytime I have like the log base a of a, we know that this is equal to what? Yep, 1. And that's because the exponent that's up here technically is 1. So if this is log base e of e raised to the x, what does this equal to? It's whatever the exponent is. Yep, so this one would be x. And then here, I've got ln of e, so log base e of e cubed, what is that?
3.
So I've got x minus 3 equals log base e of e to the 3 is 3. So I actually just made this problem way easier. Now we could have done it just like the previous problem. It just wouldn't have had all the factoring. But I just add this over. So x equals 6. Okay. Now, if I had done it the way I did the last problem, the log of a quotient is equal to the difference of logs and vice versa. So this would have been the ln of e to the x over e to the 3 is equal to the ln of e to the 3. And then I would have said, okay, well, they have the same base, so I can set the stuff inside equal to each other. E to the x over e to the 3 equals e to the 3 multiplied e to the x equals e to the 6. Same base, so x equals 6. Which way did you prefer to do it?
The first one.
Yeah, the first one. So knowing these properties of logs can obviously help make your life easier. I'm going to get the same answer either way, but if you can do it like this, so much easier. Okay? So don't forget all those properties, even though they were on the last quiz. Which I did great. I need to make sure I put them in. I think I did, but... anyways, problems 11, 15, 21, 27, 41, 49, 57, 65, and 69. I know it kind of seems like a lot, but I'm trying to give you some variety for practice, like what we did. The section for tomorrow I don't think has any notes. It's like just some word problems and stuff. So just be aware of that. We're probably looking at a quiz on Friday. Yep. Wednesday. So unless tomorrow takes a really long time or something, or if y'all have a ton of questions or whatever, Wednesday I'm probably going to be a notes day for chapter 5. Obviously we'll be done with chapter 4, but I don't want to have, since we missed days, quite a few days already, I'm going to give you like Wednesday to do notes for chapter 5, which I think starts trig. Anyways, so you'll have some days to like work on notes, or like that day to work on notes, and then we'll do quiz Friday and probably test next Tuesday, and then we'll officially start chapter 5 next Wednesday. So we'll kind of play it by ear, but just so that y'all know where we're at and have something to watch notes on Wednesday. But we'll see where we're at the end tomorrow, and I'll let you know for sure. So.